Packages to open. Starting with Zener diode. I'm not sure if this would be a specific part number or a kit of parts. I've ordered both types of orders. Looks like a kit with a bag of individual bags with handwritten labels. So I see 15 volts, 8.2, 12 volts, bunch of values, 70 pieces, 14 values, 3.3 volt to 30 volt assorted Zener diode assortment kit set electronic. Oh, only 99 cents from RR0493. So you get all these hand-labeled values. Okay, Zener diode, and the voltages are as listed. You get 5 of each, so you get 70. And again, as if horizontal description wasn't enough, they're giving you the vertical description just in case. So this will come in handy for sure, having this kind of range of parts. So it looks like a good distribution of voltages on a Zener kit. Throw it in the pile and figure out a way to use it. This says LM2596. And it is a module, very small module, with no way in. Okay, MH Mini 360. It's clearly got in and out, positive and negative labeled. Looks like a switching regulator kind of circuit with an adjustment pot. 1x adjustable buck voltage regulator power module, DC to DC, 3.3 volt, 5 volt, 9 volt, 12 volt, 3 amp. 99 cents from Kiwi Car Parts. All right, this little regulator with a trim pot, voltage in and out, 12 volt, 3 amp reverse polarity protection on that regulator chip. So it's a step down buck converter, synchronous rectification. The input voltage range 4.75 to 23 volts. The output voltage range 1 volt to 17 volt, adjustable. The output current can be 1.8 amps or temporarily 3 amps. 96% high efficiency converter. Switching frequency is 340 kilohertz. 30 millivolts ripple with no load. So what happens with load? There is no short circuit protection, and the input doesn't have reverse polarity protection. So 12 volt 3 amp reverse polarity protection means exactly what? To the datasheet. 3 amp 23 volt 340 kilohertz synchronous step down converter, MP2307, that's the chip on there. So this converter has integrated 100 milliohm MOSFETs that can do 3 amps continuous load with the wide input voltage range of 475 to 23. They have a soft start to help prevent inrush current. The output can be 0.925 to 20 volts. Here's what a typical circuit may look like and how it may perform. Efficiency with different load currents, depending on what your input voltage is. So let's see, maximum efficiency 95% if we are running at 5 volts in and we are drawing maybe a few hundred milliamps load current. So I don't see anything explicitly about reverse polarity or short circuit protection. I see this cycle by cycle over current protection. But in quickly skimming this data sheet, I don't really see anything more discussed, even about this overcurrent protection. So maybe I would need to spend more time looking at this. I wouldn't really care about reverse polarity. I would assume I'm going to hook it up correctly, but if I try to draw too much, or if I'm drawing within my continuous current and the thing just starts getting too hot, I would like it to do some sort of a thermal and or overcurrent shutdown to protect itself. So when I get this thing up and running sometime, I'm going to have to dig deeper. The description on this is in another tongue, so I'll just have to open it to find some connectors. Those are some heavy-duty pins, and these look like XLR audio kind of jacks. And I'm pretty sure that's going to have to go into some sort of proto board, not a breadboard. 2 pieces XLR 3-pin panel mount female chassis socket connector JB. 2 of these for $2. From Jewelry Base. Who else would you buy XLR connectors from? And 3-pin XLR connectors are an industry standard for balanced audio signals. They are commonly used for microphones, but the 3-pin XLR connector is commonly used for DMX512. You can also have these 5-pin. So we're back to that project with my RS-485 differential modules, trying to get ready to plug into a DMX512 unit, because I do have a couple of DMX lighting modules. However, using 3-pin XLR for DMX512 is specifically prohibited by Section 712 of the DMX512 standard. Because obviously you can screw things up if you plug in the wrong thing, like an audio cable with 48-volt phantom power, since it's the same cable used for microphones that might have 48-volt phantom power. And also you might get people using the wrong quality of cable for DMX. If you use those audio analog specified cables and you're trying to just go on long runs to do this lighting or other control equipment instead of a microphone, you might get signal degradation and unreliable operation. So that's why they don't want to use the 3-pin. But some things do have it. Expansion board module is what they claim is in here. It does look like an expansion board module, though I don't recognize it. Oh, is this a CAN controller? MCP2515. Nothing written on the bottom. So it says H and L on those pins, and I guess that applies to the screw terminal. So is that the high and low, positive and negative of a differential bus? Looks like SPI. We got a serial clock, serial in and out, and chip select. Power ground, interrupt maybe? So I believe this will go with the onboard diagnostic OBD2 header that I recently got to try to make an automotive diagnostic interface. MCP2515 CAN bus shield TJA 1050 EF02037 receiver SPI controller IC for Arduino. $1.63 from Sensesmart. So controller area network supports the version 2.0b specification, 1 megabit per second speed, 5-volt DC power supply module SPI interface, 120 ohm termination resistors because it's a differential communication like RS-485 kind of stuff. Only uses about 5 milliamps or 1 microamp for standby current. Controller area network is a robust vehicle bus standard designed to allow micros to communicate with each other in applications without a host computer. Message-based protocol designed for multiplex electrical wiring within automobiles to save on copper, blah blah blah. Basically, you get things like an OBD2 scanner and you plug it in on this CAN bus and you can talk to the car. Find out if there's any error codes and do other diagnostic things. Also used in elevators, escalators, building automation, medical instruments, and equipment. The development of this bus started in 1983. No need to do a deep dive on this at the moment. So here's where this OBD2 thing comes in. Onboard diagnostics parameter IDs are the error codes to request info from a vehicle for diagnostics. And this query and response occurs on the CAN bus. So I need to learn all about this before I ever get started using that module, but now I've got it. Breadboard wires, and it feels like it's in a plastic enclosure. So I think this is a set of those little pre-bent 22 gauge multiple length breadboard wires. Yes. And the Scotch tape again, always on these kind of cases. So yes, you take out the wire of the correct length. These are spaced for breadboards. For example, so when you have an IC or something and you have to just go pin to pin or to a nearby circuit, you don't always want a mess of these just going close to each other, so you use these little proper breadboard jumpers. I think I need to design a circuit that uses these big long ones that go across multiple breadboards. That'd be fun. 140 pieces solderless breadboard jumper cable wire kit box do-it-yourself for Arduino, $1.75 from Horizon Electronic. You get all of these colors and all of these lengths in millimeters. You get 10 of each, and it's 22 gauge solid wire. So these are pre-shaped, perfect for spacing on breadboards. Especially, I can never have too many of these smaller ones that go 1 to 4 pins away. I'm always looking for more of these, so that's why I'm buying up a bunch of kits like this to restock what I've had over the decades. So we have a pile of Zeners, a couple of these 3-pin differential audio kind of jacks that you can't really see in the shadows. There you go. DC to DC tiny converter, a bunch of pre-formed breadboard friendly wires that lay low to the breadboard and allow you to go really close or really far without a big mess of loop wiring, and a CAN controller. I'm hoping I can build the OBD2 interface and that I can't break the car while doing so. To be continued.